Today is the second day of clear sketching, so that's what we're going to get ready to do. We're going to analyze this graph in all the different ways that we've learned. What makes this most difficult is dealing with the idea of the x to the fourth power and then solving for that. So we're going to jump right into this. And I'm going to skip over finding the intercepts at this point in time because it is an x to the fourth. I'm going to say that I have 4x cubed minus 24x squared plus 36x minus 16. That would be my first derivative. After that, we will say set this equal to 0 and factor out of 4. That will make things a little bit easier. That's still a cube function, and I can't really group it or anything like that. So if you guys go back to Algebra 1 and you think about one of the rules that you guys learned, you learned how to make factors out of larger polynomials, and you did that with the coefficient out in front and behind. And you'd write down all the pairs. You'd say, well, you're going to use the 4 over 1, and then you'd write down all the different options. You'd write down factors of 4, which would be plus or minus 1, plus or minus 2, plus or minus 4, and you'd use those to try it. So that's really what I'm going to have to do, is I'm going to use synthetic division, which means I'm going to put a 1 in here, and I'm going to try 1 first, only because I know it works, and we'll go from there. How do I know it works when I get a 0 here for my remainder? Synthetic division says you write down all the coefficients of your polynomial. You bring down the 1. 1 times 1 is 1. Add these together. Get negative 5. Negative 5 times 1 is negative 5. Add those together, you get 4. 4 times 1 is 4. And you end up with 0. So going back up to what I've written here, it would now factor into x minus 1 times, this is my new polynomial, this is the coefficient in front of the x squared, this is the coefficient in front of the x, and then I have plus 4. Good news is that I know how to factor the second quadratic. It's x minus 4, x minus 1, so 1 ends up being a double root. So my critical numbers are 1 and 4. And I'm going to test the intervals of those. So I'll put 0 in for my derivative. And when I do that, I get it with a negative number. When I put 2 in for there, it may be easier to look at the factored portion of it. So it would be 2 minus 1 is 1, 2 minus 4 is negative 2, and 2 minus 1 is 1. So I do end up with another negative here. And then lastly, I would try in 5. And when I do 5, I end up with a positive. So this is kind of odd. We don't normally see this happening, but we'll be able to look at that a little bit further once we look at the second derivative. So the second derivative is taking the derivative right here. And I only really need to take the derivative of this part right here. So I've got 3x squared minus 12x plus 9. So when I factor out a 3, I have x squared minus 4x plus 3. And I end up getting x minus 4, x minus, let me make a correction there, x minus 3, x minus 1. So I have possible points of inflection at 1 and 3. When I test those for possible points of inflection, I will see that when I put 0 in here, I get a negative value times a negative value, which is positive. When I put 2 in here, I get negative times a positive, which is negative. When I put 4 in here, I end up with positive times positive, which is positive. So what does this graph end up looking like? Well, I actually need some ordered pairs, and I'm going to just tell you what these ordered pairs are. Remember, you get those by plugging it back in here for the y equals equation. It'd be 1, 0, which happens to be an intercept, and you'd have 4, negative 27. And this value of 3, I don't have an ordered pair for that, and that doesn't really matter. I will end up just needing to finish this on the next video. I was going to try to hurry through it, but it's not going to work.